Hi, my name is Stuart Lynch, and in this video, I'd like to introduce you to TextRenderer. It's a new value and text modifier that was introduced at WWDC 24 for Xcode 16 that can replace the default text view rendering behavior and produce some pretty spectacular results. The nice thing about this is that though you need Xcode 16, it is backward compatible to iOS 17, so you don't need to wait for iOS 18 adoption. I love getting your feedback, so if you enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you ring the bell to enable notifications and get notified whenever a new video is released. And if you want to support my work, you can buy me a coffee. A link is in the description. There is a starter project for this video, and you can download it from the link in the description. There are 2 branches, so make sure you download the starter branch for the project, as it has the starter resources. The completed branch contains the completed source code for the video. Just download and expand the zipped archive. The project requires Xcode 16, and at the time of this recording, I'm running Xcode 16 Beta 3. Now, the starter project has no real code in it at all. It's just a collection of tabs in a tab view, and each one containing a single text view containing the same string, although there may be some formatting on some of the different views. Now, the starter project is created so that if you want to follow along, and I recommend that you do, in the end, you'll have a collection of views that progressively introduce you to the features of the TextRenderer, and hopefully give you some ideas on how you can introduce this into your own projects. I want to start with the basics and show you how to create a text renderer and explain some of the terms used so that you'll be able to follow the examples that are to come. In the basics view, outside the view, I'm going to create a text renderer struct. Now, a text renderer is a protocol that can replace the default text view's rendering behavior. And as a bonus, as you'll see, it is also animatable. But first, the basics. So a text renderer has one required instance method, as you'll see. So let's start by creating a struct called LineRenderer, and it conforms to the text renderer protocol. And very quickly you'll find that it does not conform to that protocol, so we can let Xcode fix that for us. And we'll get that one required draw function that provides us with a layout in a graphics context, which is an in-out parameter. So that means we can change the context with the draw function. Well, I'm going to use this text renderer and go over the 3 main components of a text renderer, and that's a line, a run, and a glyph. Now, the layout is an instance of a text layout struct, which is a value describing the layout and custom attributes of a tree and text views. We can apply the text renderer modifier to any text view by providing a defined text renderer struct. So if we apply that to our multi-line text view, we can do it like this. As you see, because our draw function draws nothing, our text view disappears. The first component is a line, which represents a single line with a text layout. And since the protocol itself conforms to the random access collection protocol, we can iterate through each of the lines using a for loop, so for line in layout. And then we can use the context's draw method to draw each line individually. So now we have our text view back. But before we draw that line, we can alter the context and modify how it draws. For example, the graphics context has a stroke property that we can use to draw a rectangle around the line, like this. So we're going to use the stroke path line width initializer. For the path, we'll specify a rectangle path in the line's typographical bounds .rect. And then for the graphics context shading, we can specify a color, and we'll use a red color, and we'll specify a line width of 2. So when we do this, we'll see that a red rectangle surrounds each of our lines. And I believe there's a bug right now, as this extra space after the second last line is unexplainable. I've received confirmation from people much more knowledgeable than I am that they too believe that this is a bug. Fortunately, this isn't going to affect us at all. Each line is composed of a number of runs. So we can step through these as well. So within the line loop, we can create a loop over each run within the line. And I can just copy and paste the same stroke from the line and just change the line to a run and use a different color, like green, and make sure that I draw the run. So let me comment out the line, stroke, and drawing lines, and it looks almost the same except that we don't have that extra space. It's not entirely the same though, as you'll see in the next example. Before we do that though, each run is composed of a number of glyphs that we can loop through too, and use a different colored stroke. So within the run loop, we'll create a for loop for the glyph in the run. Then you can just copy and paste those 2 lines of code and change run to glyph, and then change the color to, say, yellow. And make sure you also change the draw to draw the glyph as well. And then, if you comment out the run drawing code, you'll see that each individual glyph or character is outlined in yellow. Now, as this is a struct, we can create a property for the struct. And I want this to be more flexible as I explore the next and perhaps other views. So let's create an enum called outline type with 3 cases: line, run, and glyph. Then, as a property, create a let that is an instance of this outline. Of course, our TextRenderer modifier will complain, so let's pick one of those cases like the run case. Well, nothing changes here, but what we can do is modify our code using if statements to only draw the component if the component matches our outline type. So what I want to do is surround each of the 2 context statements in each loop with an if clause that will only execute for the selected outline type. I'm going to surround these 2 commented lines here with if outline type and is equal to the line case. Similarly, I can do that for the run in the line loop. I can check to see if the outline type is equal to run. And then we can do the same for the last glyph in the run loop, where we check to see if the outline type is a glyph. And we see that since we passed in the outline type of run, we're seeing just the green outlines. And if I change the argument, then I can see that we get the different outlines based on the case selected. Now, I don't like having structs that I will reuse in other views contained in a view. So what I can do is I can create a new group in my navigation tree, and I'm going to call it TextRenderers. Now what I want to do is I want to cut out this entire text renderer here that we defined in this struct. And now in Xcode 16, we can just select the TextRenderers folder and then just paste. And it will automatically create a new Swift file with the contents of my clipboard, and it recognizes that this is a struct called LineRenderer, and that is what it's going to use for the file name. All I have to do is import SwiftUI. Let's move on to the second view, the Basics 2 view. Here I'm displaying the same text view, but what I've done is broken it up into 3 views that I have created as constants, and then I use string interpolation in my multi-line text view within that navigation stack to present the same single view. So what I can now do then is apply my new text renderer to this particular text view here. And I'll specify the run case. Now you can see we get that same outline as before for our runs. And if you recall, I specified that each of the borders were based on the run's typographical bounds. Well, what does that mean? Well, what we can do is we can apply some modifiers to each of our constants. So how about bold for the topic, a font of title for the OS, And let's make introduced italicized. Now you can see a difference in the border. We can modify the content of a run based on whether or not we have a specific modifier applied. So this is all I want to talk about in this view. Let's move on to the next view and see how we can use that information. This next view starts at the same place that our previous one did before we applied our modifiers. What I want to do now is to create our own text attribute, kind of like bold or italic, and I'm going to call it a highlight attribute. And this is really quite straightforward. You simply create a struct and give it the name highlight attribute, and just make sure that it conforms to the text attribute protocol. Nothing goes in the body of the struct. It's simply an equitable and hashable value that you can use or to attach to a text view and that text renderers can query. So now that we have that, we can attach that to our OS variable using a custom attribute modifier. With this in place then, I'm going to create a highlight text renderer. Remember, a struct that conforms to the text renderer protocol, and we'll let Xcode implement that draw function for the protocol conformance. Then we can, within the body of the draw function, loop over each line and the runs within each line. And then we'll check to see which one has the attribute attached to it and modify the context for that one. So to check, we'll check the run to see if it has that attribute. And we do that using the run, where the index is the type highlight attribute .self. And we'll check that it is not nil, meaning it's been applied. If that's the case, then we'll want to modify the context. Else, we'll simply use the context to draw the run. So what we'll want to do here then is to add a yellow background in the form of a rectangle shape. And we do that by creating a rectangle from the runs typographical bounds.rect. And then we can create a path using that rectangle's path in that rect. Next, we can then use the context fill method, where the path is that path, and the graphics content shading will be the color, let's say yellow, with an opacity of 0.6. Then we can use the context to draw the run. Nothing's changed yet because we have not told our text view to use the highlight renderer. So let's do that now and apply it to the text view. And there you have it. Now I want to move this renderer and text attribute to its own file. But before I do that, I'm going to move the highlight attribute to below the text renderer. And I'm doing this because when I cut it out, I want the highlight renderer to be first, and that will be the name of my file when I paste it into the text renderers folder. So as I do that now, the new file gets created, and I just have to import SwiftUI. So I can return to my text attributes example view now, and let's say I want to highlight the text view for this WWDC24. I can simply do that by applying that new custom attribute to it too. Let's take a look now at how we can really make use of the text renderer to create some different effects. Now I'm going to warn you that I'm not the greatest designer or graphics artist, so I'm going to show you how to create the effects, and in the end I'll point you to some other resources for some more detailed and fancier examples. We know that we can access each line in a multi-line text view, so what we can do then is apply an effect to it as to change the presentation of that line using a text renderer. And the simplest is to change the opacity of alternating lines. So I'm going to create a new text renderer, and I'm going to call it Alternate Line Renderer. And I'll make sure that I include the requirement protocol draw function. Now, since our layout conforms to the random access collection protocol, we can use that for loop to step through each line in the layout. And we can also capture the index of the line if we use the layout enumerated. And then we can check to see if the line is even by checking to see if the index is a multiple of 2. If it is, then we can use the context draw method to draw the line. So let's apply that to our text view, the text renderer for the alternate line renderer. We see that the first and third, the index 0 and 2, lines are displayed, but the second line, the one at index 1, is not. We can use this knowledge then to apply a context modifier on the lines if the index is even, meaning reduce the opacity, and then leave it as is if not. So let's do that right now. So in the even case, we'll alter the context so that the opacity is set to 0.5. When I do that though, the opacity is set for all lines. And this is because once I set the opacity that is at the 0 index, it stays that way for all subsequent lines unless I change the opacity back to 1 in that odd case. Now it's getting me what I want. But there's another way to deal with this, and that's to make a copy of the context in the even case, and then change its opacity there. And then use that copy context to draw the line. In the else clause, though, we don't need to set the opacity because the original context is still set at the opacity of 1. It was never modified. So let's move this new renderer to its own text renderer folder, making sure that we import SwiftUI. Let's take a look at another example where we can angle each line in our text view. So I'm going to start by creating the new angled text renderer struct, and I'm going to call the draw method in here for conformance. Then again, we can iterate through each line using for line in layout. And then we can use the context rotate method to rotate by an angle of 5 degrees. And then make sure that we use the context to draw the line. And then if we change the text renderer in our view to this new one, let me just comment out the first one then and create a new one where our text renderer will be using the angled line renderer. Now this may be what you want, but it would be better if the first line wasn't angled. Plus it appears that the angle is cumulative, so this first line is 5 degrees, and then the second line will be 5 plus 5 and so on. So what we can do then within here is we can fix it by using the index on an enumerated line again. So we'll use an index in the line in layout enumerated. First though, we'll create a copy of our context for a copy context. And then use that context for our rotation. And then we'll use the double of the index times 5. So it'll be 0 on the first iteration, so 0 rotation, and then use the copy context to draw the line. This is better. Let's cut this out then and add to the text renderer for our new folder. Let's get more granular then. We've modified runs using the text attribute and a line by looping through each line. Now how about each individual character or glyph? So I'm going to create a new text renderer and I'm going to call it up-down renderer. And I'll make sure I create that draw function too. Now we can loop through each of the lines using a for line in layout. And then within this for loop, we can loop through each of the runs using for run in line. And that's going to get us down to the glyph level. What you'll see though in other examples that I'll reference is that they use a text layout extension to combine these two loops into one. So let's do that too. In the TextRenderer folder, create a new file, and you can call the file text.layout plus extension. So when you create a new file, it's completely empty. So we'll need to import SwiftUI. And then I'm going to create an extension for text layout. That's text.layout. So what I want to do is I want to flatten the lines and runs together. So I'm going to create a computed property called flattened runs that will be some random access collection where the type is a text.layout.run. And then in the closure, since this is a random access collection, we can flatten all the runs from all of the lines into a single collection using a flat map. Now back to our original text renderer, we can replace both of the for loops with simply one for run in layout.flattenedRuns. Well, what we want to do is if the glyph is an even index, we can translate it by moving it up in the y direction by 5. And if it's odd, we'll translate it by dropping it by 5. So within this loop then, we're going to create another for loop where we'll need access to the index in the glyph in our run enumerated. And since we'll be changing the context on each one, we should make a copy of the context so that we can always get a fresh start within our loop. We can use this copy to check to see if the index is divisible by 2. And then we can use the copy context to translate it 0 in the x direction, but 5 in the y direction. If it's not a multiple of 2, then we can use an else, and then we can use the same translation but set the y translation to a -5. And once the translation has been made, we can use the copy context to draw the glyph. Let's apply this TextRenderer modifier then to our text view. So now we have staggered letters or glyphs within our text view. Now we can shorten this if-else clause by using a ternary operator. So we can just take that copy context, translate by x0 and y, and then within the y, check to see if the index is a multiple of 2, and if so, then we'll apply 5, otherwise a -5. So again, let's cut this out and we'll create a new file for this text renderer. Let's create an animatable glyph renderer then. And we're going to animate that up-down transition. So I still have that cut renderer on my clipboard, so let me just paste it into this view, but I'll change the name to animatable up-down renderer. So what we want to animate is this y offset. So within the text renderer struct, I'm going to create a variable that I'll call y offset, and it's a double. To animate this, then, we need to create a computed property that's called animatable data. And the type is going to be the same type, which is our y offset. So that's going to be a double. This is going to require a getter and a setter. So the getter will simply get the Y offset, and the setter will apply the new value to the Y offset. So we can replace the hard-coded 5 in our code then with that Y offset. We can apply this text renderer then to our view, passing in a desired Y offset, say 5. It's not animating though. So in order to handle that, we can't pass in 5. We'll need to pass in some sort of a value that we can animate in our view. So let's create a state property in the view that will be Y offset, which is a double, and initialize it as that 5. And then use that to pass into our animatable up-down renderer. Still not animating though because we haven't told it to change. And we do that in our view. When the view appears, we can create a with animation block. So on appear, and then a with animation block, and we can specify an ease in animation with a duration of say 2 seconds. And then we can specify that it repeats forever and set the auto reverses to true. Then within the block, you can reverse the Y offset by multiplying by -1 and assigning it back to itself. And we can see it's working. But we could also have just as easily used a star equals, multiply equals -1 like this. And you can see we've got that nice up-down animation. As I said, there are way better examples of what you can do with this, and I'll leave links in the description for you to check out. Some of the math in those examples can get pretty complicated, so that's why I stuck with this simple example so that you can get an understanding of what's going on and hopefully digest some of the more complicated context modifications offered in blogs linked there. So before I finish, let's just move this text renderer into our text renderer folder. So that's it for this video. I hope you've learned something new here that you can use in your projects going forward. If you've enjoyed this, please give it a thumbs up and leave me a comment below. Make sure you subscribe to my channel and enable notifications so that you are made aware of new videos that I release. But you can also download my free channel listing app to be able to search for and find content from one of my over 300 Swift and SwiftUI related videos. Thanks for watching.